Okay, student, today I am in front of you with new topic mixture. In last lecture, we have discussed about the mixture and compound and this difference between mixture and compound. Today, I am going to explain you that what is that term mixture. Even I have already explained you that what is mixture. Today we will discuss about the classification of mixture. Actually, around us there are different kind of mixtures. Some mixtures are homogeneous and some mixtures are heterogeneous. Before explaining this, homogeneous and heterogeneous, I would like to explain you mixture again. That what is the mixture actually? As I told you, mixture is formed by two or more substances. Means wherever there will be two or more substances and they mix together, and then whatever is formed, that is called the mixture. Just like I'll give you very simple example. At your home, your mother prepare one called khichdi, we called, right? In khichdi, what she used to do, rice and different kinds of pulses and vegetable, she mixed them, and that mixture become that particular substance whatever has been formed after mixing so many pulses, that is called mixture. As it is when two or more substances combine together or mix together physically, then mixture is formed. Now the question is there that we are having so many kind of I am having salt solution. Whenever we used to prepare salt solution, there is no any difference between salt solution and pure water. They look similar. And another side, I am having a soil solution. Soil means water and soil. At the same time, I am having a mixture of water and sand. You can easily understand that what is homogeneous and what is heterogeneous if I'll give you an example. Very simple example I am giving you here. Salt solution. And this side I am writing sand solution. Whenever I used to say salt solution, it means salt and water. And when I used to say sand solution, what does it mean? It means sand plus water. Here I have written H2O. You will have to know that this H2O, this is the chemical formula of water actually, right? Salt solution I have written salt plus H2O. Sand solution I have written sand plus H2O. Now you can do an activity at your home itself, right? Take a glass of water and mix 2 spoon or 1 spoon of salt on it. What will you find when you will stir it? Stir it means usko hilayenge aap. You will see that the salt has been eliminated from that particular liquid. Means initially when you add salt on it, the salt and water was both were visible. But when you stir that particular solution, now the salt is not there in that particular liquid. It is just looking like water. Now the question is that what happened to solid? That salt, actually salt completely mixed with water. Whenever two or more substances mix together completely, just like salt and water. Another example I am having sugar and water. Whenever they mix water, whenever the sugar and water mix, what happens? They become unite. It seems one. Means the sugar particle cannot be seen with our eyes. Similarly, salt solution and the salt particle cannot be seen with our eyes. So such solution whose particle cannot be seen by our naked eyes and they completely mixed, such solution are called homogeneous. Means two components are there, water and salt are there, but whenever we used to observe it, it seems like one. Such kind of solution are known as homogeneous solution. As I have written here, true solution. True means these are the true solution. Whenever anybody will ask you what is the difference between mixture and solution, even solution is a part of mixture, but what will be the difference? Actually, this is also a mixture. I am having chalk powder and water solution, that is also a mixture, right? I am having milk is a mixture. Then what is the difference between solution and mixture? So whenever I used to explain the solution, I used to say the product which is made up of two or more substances, but looking wise one. When these components completely mixed up, one dissolve in another. Just like I have given you an example of salt and water. Salt completely mixed with water. It means salt is dissolved in water. Now it is seen as one. Such kind of solutions are known as true solution. Completely mixed means solution. Even it is a part of mixture. Another kind of mixture are heterogeneous. It is homogeneous means when the components completely mixed. So simply heterogeneous means when the particles could not completely mixed up. I have given you an example, means there again they are classified suspension and colloidal solution. Now we will have to understand that in salt solution the particles were not seen. In sand solution, when I have taken sand and water, I can easily observe the particles of sand in that particular water. You can do an activity, have a glass of water and mix sand on it. You will see that the sand could not completely mix up with water. The sand particle can easily seen with our eyes. We can see the particles of sand in that particular mixture. Such kind of mixtures in which the particles of another substance can be seen with our naked eyes are known as suspension. In homogeneous, I told you that when two or more components combine together or mix together completely, that is called homogeneous. Now I am asking you, when two or more components could not completely mix up together, those are called heterogeneous, and these are called a suspension. Right? In suspension, if the particles can be seen with our naked eyes, just like I have given you an example of sand solution. Sand particle can be seen with our eyes, naked eyes. It means that is suspension. Another kind of solution are there, colloidal solution. To explain the colloidal solution, I will give you an example of that colloidal solution. You have seen blood. Whether you are seen the blood, human blood, you can see that that particular blood seems as a liquid. It seems just like water. Water is colorless, but blood is red colored, according to us. But originally, there are some particles. What particles are there? There are WBCs, white blood cells. There are RBCs, red blood cells. There are blood platelets in blood, which are diffused in a liquid called plasma. It means the mixture in which the particles are diffused in such a way that which cannot be seen with our naked eyes. Milk. Commonly at our home and generally at morning or evening we used to drink milk. Right? In milk you cannot find out the particles. But in that milk is also a mixture of fatty acids and water. But those fatty particles cannot be seen with our naked eyes. Whenever we used to observe it with the microscope, when we examine it whether we are having milk or we are having this blood. Whenever you used to go for blood test, in blood test, the report you have seen RBC this much, WBC this much, hemoglobin this much, blood platelets this much. Means the number has been given that there is hemoglobin in blood, there is blood platelets are there, so many other particles are present in blood, but those particles we cannot see with our naked eyes. Whereas in another side, in scent solution, the scent particle can be seen with our naked eyes. So the definition of colloidal solution means those solutions, those mixtures which seems as homogeneous. What? Which seems as homogeneous, but originally they are heterogeneous. Such kind of solutions are known as colloidal solution. Again I am going to explain what are the homogeneous and what are the heterogeneous. Homogeneous means in which the particles completely mixed. We cannot differentiate those particles. We cannot see with our naked eyes. True solution. In heterogeneous, the particles cannot be mixed together completely. But there are also two types. Suspension, the particle size is very large. Right? Large means, just like scent solution, you can see the scent particles through our naked eyes. In another side, the heterogeneous is also a type of, there is colloidal solution. In colloidal solution, as I told you, those solution which seems as homogeneous means you will see that there is no any particle, there are no any particles of another substance, but originally there are the particles. Just like I have given you the example of milk. In milk you have seen fatty acids are there in water, but those fatty particles are so smaller, cannot be seen with our naked eyes, but they can be examined through different activities. Just like one is Tyndall effect, which we will discuss later on. Now I will give you the particle size. Actually, particle size, this is very small, this is suspension you can say, and this is colloidal solution you can say. The range of particle is 1 nanometer to 1000 nanometer. This range of particle means 1 nanometer to 1000 nanometer means the diameter of particle. This is the diameter. If the diameter of particle means, just like scent particle you have seen, scent particle its diameter, the diameter is diameter range. If that diameter range is 1 nanometer to 1000 nanometer, it will be colloidal solution. If it will be larger than 1000 nanometer, what? If it is larger than 1000 nanometer means the particle size means the diameter of the particle. Diameter of particle is more than 1000 nanometer, it will be suspension. While if the particle size is smaller than 1 nanometer, if the particle size is smaller than 1 nanometer, then it is said to be as homogeneous solution, or you can say true solution. Now you are having three. One range is 1 nanometer to 1000 nanometer. If the particle size is from 1 nanometer to 1000 nanometer, it will be the type of solution colloidal solution. And if the particle size is more than 1000 nanometer, right hand side of this, it will be suspension. And if the particle size is less than 1 nanometer, then it will be said to as homogeneous mixture, as well as this is called true solution, right? Now the next topic we will discuss in next lecture. Thank you.